Which one? Number of atoms, this one, is it still not clear for you? Okay, tanya tadi. So how we got 6, isn't it? How we got 6 atoms in one structure, one unit cell of HCP. Okay, so if you look at this hexagonal, okay, if we draw the top view of this hexagon, there are one half a sphere of the atoms, and there are 6 at the corner. Okay, the portion for the center atoms is half, and the portion at this corner is 1/6. Okay, how do you get 1/6? Imagine there are another here, another here. This one is 1, 2, 3. Okay, and it cut in half. So if this sphere divided by 3 and divided another 2, because top and bottom of the sphere, okay, this is a sphere, and atas ni dibagi dengan 3 lagi. 1, 2, 3, ni bottom 1, 2, 3. Okay, and this is 1/6. So that's the reason we got 1/6. So how many of them in the first layer from the top view? It is 6. So multiply by 6. So therefore it's equivalent to 1 atom. Okay, 1 atom. And this is half atom. Remember, this is only at the top side. So you have to multiply by 2. This half and another 1 atom. So you got this at the top, the total at the top is this part, you have 1 plus half atoms, and at the bottom part also the same, 1 plus half atoms, and at the center you have 3 atoms. So you total up, it's equal to 6 atoms. Okay, sekarang dah faham? Now you understand? Lain? Soalan lain? Kira-kira lah, lebih kurang lah. Definition just a bit. Contohnya differentiate between the characteristic of the or the mechanism of atomic bonding. You need to sometimes able to distinguish what is the difference between ionic bonding and covalent bonding. Okay, the category of bonding, the relationship between the what we call it, atomic structure and the ionic bonding. Okay, and then the density. If we talk about unit cell or crystallography or crystal structure, okay, usually it is about FPF, atomic packing factor, and density. Sometimes the question asks you to get a relationship between lattice constant. What is lattice constant? Okay, and the radius. Okay, atomic radius. Alrighty. Okay. So if we reverse to the previous slides, for example, like this one. Okay. So what is the relationship between lattice constant and the radius of the atoms? Okay. Sometimes the question asks you to derive this concept. Okay. You need to be able to see the 3 dimension of the unit cell. Okay, this is the unit cell of BCC. Try to look at how the atoms arrange and try to relate between this lattice constant, okay, this lattice constant with the R, where if we look at this structure, the distance between this point and this point, okay, we can have one relationship with, which is the length of this structure is 4R. So sometimes you need to derive this, okay. Sometimes you need to determine the density and try to compare with the actual density. What is actual density? The one that we obtained from the experimental. Okay, experiment. This one is the actual because we consider all the environmental aspect and many other things. Okay. So actual basically the one that we do in experiment. Theoretical basically this is the theory how the density of material is created based on the crystal structure. This crystal structure where we consider the size of atoms. Okay, different material has different size of atoms and different atomic mass. Okay, so that's the reason this one is sometimes not. It's not sometimes all the time it's not similar with the actual density. That's all I did. Right. The concept is remember we have this ratio. Okay, this ratio which is C over A. This one C over A is equivalent to 8 over 3 square root. Okay, so now we got a relationship between C and A. Okay, so look at this A. Okay, remember when we try to relate between the how packed is it based on how many atoms and its volume in the cell divided by the size of the cell. Okay, last time when we discussed about the FCC, okay, it is quite simple because it is just a cube structure where all the lattice constant or all the length of the cube is equal, okay, which is A. However, for this it has another constant which is C. Okay, but from the ratio between the C and A is given, which is C over A equal to this value. Okay, kalau you calculate this one is equivalent to what?
Six, 3, 3.
338. Okay. So what is okay now we know basically the concept is we need to cancel the unknowns, okay, which is R. Okay, the variable here is R, so it should be able to if you able to relate, because we know that the volume of the cell contain the constant such as C and A, because it is a hexagonal what we call it, prism, where the cross section is a hexagon. Okay, so it has two constants. What you have to do, since above has R, so you need to relate this constant with R. Okay, so that you can cancel all the length unit in the volume of unit cell. Sorry, unit cell or sphere. It has a R constant. Okay, so how to relate this? It is very simple. As you can see here, okay, look at A here. Okay, this A. What you can relate is the length of A in this equation is equivalent to 2R. So C equal to 1 over 6 3 3.633 multiplied by 2R. Okay. So C equal to 3.266. Okay. R. Oh, sorry. Tak perlu pun. Not necessary. Okay. C equal to 2R. Okay. So next is okay. So how to measure the volume? Volume of cell. Okay. So first, what you have to do is you need to calculate this area of this one. So what is the area of this one? Macam mana nak calculate dia? Tahu tak nak calculate segitiga? Tengah kali 2R kali 2R.
Ya, betul.
Betul tak? The height here is 2R. Betul lah ni? Saya tanya ni, setengah kali 2R, 2R. Betul ke? Kira area? Betul ke? Ni, equation ni betul? Betul ke tak? So, jawapan dia sama dengan berapa? 2R kuasa 2. 2R2. Betul eh? Betul ke tak? Saya tanya ni. Ha? Tengah kira. Betul. Okay. Next. Juga kali dengan 6 right? Okay. So 2R2. Then there are how many of them? One, there are 6 triangle here. Okay. 6 triangles. So you need to multiply by 6. Okay. So the volume cell equal to 6 multiplied by 2R2 divided by multiplied by C. So what you get is 1.633 multiplied by 12, you got 19.596. Okay, so n equal to 6. Okay, 6 multiplied by 4 divided by 3 multiplied by pi equal to 25. Oh, ni salah ni. So ni salah ni area. Macam mana kira segitiga sama sisi ni? This triangle. Semua tak boleh. So the volume of cell is equivalent to area of hexagon multiplied by C. Okay, so it is equivalent to 12 square root 3 r squared, and C equal to 1.6. Okay, so equivalent to 12 square root 3 r squared multiplied by 1.63328. Okay, sorry. A, since we know that given A equal to 2R, so B cell equivalent to 12 multiplied by 3 square root R square multiplied by 1.66, sorry, 633 multiplied by 2R. So what is this answer for these ones? Oh, sorry. Area, this one is, sorry, this is 6A, this is 6A. Right, what is the answer for a volume cell? The volume for the unit cell. Anyone? Nilai R tak ada. Leave as this constant as R. The answer must be something in R. Berapa jawapannya? Okay, yes. 33.94. Okay, so remember APF, when we talk about APF, okay. Right, so APF is how packed the space, okay? So we need to know the volumes of atoms divided by the space, volume of unit cell. Okay, this is common. When we translate the factor of packing in any cases, for example, how pack people in one room, something like that. So we usually calculate the ratio between the item inside the space in terms of value divided by the volume of the room itself. So sama lah macam this case of atoms, how atom they arrange in that particular cell. So we can determine the packing fraction of atom divided by the unit cell. Now, just now you gave the answer. Okay, so now the volume of atoms, we know that, yeah, how many atoms inside the HCP? So it is actually 6 atoms of the number of atoms is 6. So 6 atoms multiplied by the volume of sphere. So, because we assume that the atom in the shape of sphere. So sphere formula is 4/3 pi r cube divided by 33.94 r cube. So we can cancel r. So what is the answer for this one? So what is the answer?
74.
0.74. So it is similar to FCC. So this is how we determine. So the BCC also you can determine by using the same concept. Okay, BCC, we know that BCC, it has this kind of atomic structure. You have 1/8 at the corner and 1 solid at the center. Okay, so the atoms is continuously connect or touch each other from this point, this atom at the center and at this corner. Okay, so this one is 4R. So using the same concept, I think you can determine. Do you have any problem to determine the APF for BCC? This is BCC. Okay, you can determine the APF for this one. So similar. Okay, you have to cancel the value of R for both top and bottom for the APF. For BCC, it is the volume of atoms and the volume of cell. Okay, then you got the APF for the BCC. Okay, any other question? What about the direction? Miller index. Last time we discussed about this. Do you now are you able to determine the Miller index for example, I give you one example, so you can do it together. So let's say I give you this direction. Please index this direction. What is the answer for this one? Remember the system for Miller index is the axis system in the Miller index is this is X, this is Y, and this is Z. So what is the Miller index? 1, 101. Okay, any other answer? Is it correct? So can you explain the procedure to obtain this answer? Siapa yang bagi jawapan tadi? Boleh tak? Can you please explain the answer? Head minus tail. Very good. Head. What is head coordinate? What is the coordinate for the head? Good. 1, 1, 1. And what about the tail? 0, 1, 0. So first, remember you have always defined the axis for x, y, and z. So this is 0, 0, 0 here. So from here to here is 1 for y axis. From here to here is 1 for the x, and from the center to the top is 1 for the z direction. Okay, if you look at this position, the head of this direction, it is actually 1, 1, 1. And if you look at this tail, it is actually there's the position at x direction is 0, y direction is y, and sorry, 1, and z is 0. So that's the reason you get head minus tail. Minus tail is equivalent to 1, 0, 1. So for the direction, you don't have to put comma between all the value. So you need to put a square bracket. So this is the Miller index for this direction. Okay, another example. Okay, so what about this? Okay, anyone? Buat yang lain, walaupun you tak berani nak bagi jawapan, tapi you have to do it. You have to try to do this exercise so that you don't have to waste your time to spend another time to study and try to recall whatever the lesson I gave in the class. So please try, okay, how to index this direction. Anyone?
-1, half, -1.
-1, half, negative. All right, good. 2 bar, 2.
1,
1,
2.
2 bar. Okay, good. Right. How do you define it? Please explain.
For the head is 0, 1, 0.
0, sorry. 0, 1,
1, 0.
Okay,
Then
for the
for the tail is 1, half, and 1.
half,
Then
so
time 2.
8 minus tail, you get -1, half, -1. Okay. So you need to times 2. You get minus 2, 1, minus 2. So the Miller index is 2 bar, 1, 2 bar. Square bracket. Okay, square bracket. Do not give a wrong answer or uncertain answer. Wrong answer is 2 bar, 1, 2 bar is a bracket. And uncertain answer is, this is uncertain answer is 2 bar, 1, 2 bar, like this. This is uncertain, so the answer is wrong. Only write this answer and then I will give a full mark. Okay, do not write, do not ask me to choose which one is correct. Okay, and also don't give this answer like this without the bracket. Okay, it is not an index. It is not Miller index. Okay, Miller index must be written like this one. Okay, so ada tak yang masih lagi belum faham macam mana this index diperoleh? Yang malu-malu cakap je. Siapa yang dah faham tu tak apa, it's okay. Semua okay ke? Suara saya tak perlu test lagi. Okay, good. Very good. Very good. Alright. Okay. Last one. Alamak, macam mana ni? Tak payahlah. Saya nak suruh. Okay. Last, do this exercise. Okay. I give you exercise for Miller index. Alright. Number 1 is determine Miller index for the following. 1 is 102 bar. 2 is 312 bar. Number 3 is 100. Number 4 is 210. Number 5 is 1 bar, 1 bar. Okay. Take this and do the exercise. Later I will create the link for submit this short assignment. 1.1. Oh, sorry. 2.1. Okay. So do this exercise and I will create the assignment that you need to submit at the e-learning. I will share the link for submission later. Okay, boleh?